Welcome to Engineers Mindsets. Now let's say we have to evaluate limit as x tends to 1, y tends to 0 of 3x squared plus y squared plus xy. Okay, so as always, try by direct substitution. Okay, so we simply try by direct, substitution. All right, so we have limit as y tends to 0. So we simply send in x first. We're testing when x tends to 1 of the given function 3x squared plus y squared plus xy. Okay, so we have this. So this simply means wherever you see x, simply put in the value as what? 1. That's by direct substitution. So I will have limit as y tends to 0 in place of x now, I have 3x squared here. So in place of this x squared, I'll simply put in 1. This becomes 3 into 1 all squared, okay, plus y squared, plus here I have xy. So in place of this x, I'll simply put in the value as 1 times y. So I have this. Okay, so this becomes limit as y tends to 0, okay, of course 1 squared is 1 times 3 still gives us what? 3, plus I have here y squared, plus I also have here 1 times y simply gives me y. Okay, so at this point I have all values or variables in y, so I can now simply what? Put in limit as y tends to 0. So wherever you see y in this equation, simply substitute the value of y as what? 0. So this will simply be equal to 3 plus, in place of y squared, I simply have 0 all squared, plus in place of y, I simply have 0. Okay, and this will actually give me 3 plus 0 plus 0, which is equal to 3. Okay, so the limit as x tends to 1, y tends to 0 of the given function fxy is simply equal to 3. And this limit actually what exists. So it is not indeterminate. It actually exists at those points. All right, guys. So that becomes the answer to that problem. All right, guys. I hope you find this video very interesting. Please, if you do, share your thoughts in the comment section. I will see you in the next video with more wonderful questions on limits and functions of several variables. Please, if you're new to the channel, don't forget to hit the subscribe button to keep on getting updates on content like this. Thanks, guys, and cheers.